All right, we are moving on to deductive reasoning. So if you need to pause the video to get some of this stuff, deductive reasoning is the opposite of inductive. So you're using facts, definitions, or accepted properties and laws of logic to make a logical argument. So you're going the other direction. You're taking a general fact and making a specific conclusion. So for example, I got this from Mr. Dowd too, by the way. A general statement that you might learn in science, all birds have feathers. I can use that general fact or property to then say crows have feathers. Crow has feathers. It's not very grammatical, sorry. Okay, so you're going from general to specific. All right, the laws here. And here's where people sometimes start to get a little confused. So the law of detachment. If the hypothesis, remember the hypothesis is the P, okay, and the Q is the conclusion. If the hypothesis of a true conditional statement is true, then the conclusion is also true, which I think makes sense. If you know it's a true statement, if it's a true if-then statement, and the first part is true, the second part is also true. An example is if I know this is a true statement, if a triangle has two sides, then it has two congruent sides, If a triangle has two congruent sides, then it's isosceles. That if it's true that a triangle has two congruent sides, then it is also true that it is isosceles, because that is the definition of an isosceles triangle, a triangle with two congruent sides. So that is the law of detachment. The law of detachment is saying if the whole statement is true and P, the hypothesis, is true, then Q, or the conclusion, is also true. Okay, so that is called a law of logic. What are the laws of logic? We're going to go over two today. There are many, but we're introducing you to this. All right, the second law, and I will go over this several times because it can get confusing, is called the law of syllogism. The law of syllogism, that's how you pronounce that. Okay, so the law of syllogism, you definitely are going to want to write this part down. Okay, if hypothesis P, then Q, and I did a shortcut over here. So if P, then Q. If Q, then R. Okay, so then if Q, then R. So if you're then making a second statement that starts with the conclusion of the first and has a different conclusion, that's why it's called Q, then R. If both of those are true, then you can assume if P, then R is also true. Okay. And we'll look at that with a specific example in a minute. With the law of detachment, it's saying if the hypothesis of a true conditional statement is true, then the conclusion is also true. Okay, we just went over that. Okay, so what example are we on here? I kind of lost track, to be honest. 7 maybe? I don't know. All right, again, you can summarize the important information, that's fine, but there should be something written down. All right, if two segments have the same length, so if you have two segments with the same length, then they are congruent. So that's my conditional statement. You know that BC equals XY. Using the law of detachment, what statement can you make? So if you need to go back, so if I know if two segments have the same length, that's the hypothesis, right? That's my P, then they are congruent. If it's telling me, if I know the first part is true, BC is equal to XY, so that's saying that P is true, what statement can I say? If BC equals XY, then they are congruent. That's it. Okay. All right, if possible, so it might not be possible, if possible, use the law of syllogism to write a new conditional statement that follows from the pair of true statements. So I'm just going to put up here in the top, here was the law of syllogism. If P, then Q, then Q, then R. If both of these are true, then if P, then R is also true. So that's your actual law of syllogism. I'll put it up here. So let's label our statements and kind of see what we have going on here. If x squared is greater than 25, so let's make that our P, our first hypothesis, then x squared is greater than 20. That's my Q. Okay. If x is greater than 5, okay, and the next part here, it's also different. If x is greater than 5, that's new, so we'll call that R. Then x squared is greater than 25, and that would be P again. Okay, so I have P, then Q for my first statement, R, then P. So does that seem like that follows the law of syllogism up here? P, then Q, Q, then R? I would say no. So we can't use the law of syllogism. Doesn't mean it's true or false, we just can't use that. Okay, and let's go ahead and skip part B also, just because I know this is getting very long. Okay. Number 9. What conclusion, all right, we got 2 more examples, by the way, if you're wondering how long this is going to go. Number 9, what conclusion can you make about the product? Remember, product is when you multiply of any even integer and any other integer. Okay, so we're going to do inductive and deductive here. So let's start with inductive. Inductive is when we try specific cases. So let's try an even integer and an odd. Why not? An even times an odd is even. Let's try an even times an even. Still even. Okay? So my conclusion might be it is always even. So there's absolutely nothing wrong with inductive reasoning. It's a great strategy to use in math and in life to just try it out and see if you see a pattern. Okay? Deductive, you're doing more of a formal proof. All right? So let's say if we want an even integer, let's let 2n, why 2n? Because 2 times anything is even. So 2n will be any even integer. And I could have said 2x or 2b or whatever. I'm just kind of using algebra. Okay, we're going to have x be any other integer. So x will be this part, any so you're doing more of an algebraic proof. Okay, then 2n, that was my even integer, times x, what does that equal? That equals 2nx. And 2nx, since it has a 2 in it, is divisible by 2. So it is even. Okay, so those are I'm just showing you in example 9, okay, how to use both inductive and deductive reasoning to come up with the same conclusion that it will be even, that the product of an even integer and any other integer will be even. So inductive, you tried out some specific examples, okay, and deductive, you're kind of using algebra. And depending on the situation, one might make more sense or be easier to use than the other. So that's why we're teaching you both. All right, 10, our last example. If there's more, we'll skip them. Decide whether inductive or deductive reasoning is used and explain your answer. Okay, so part A, again, you can summarize if you want to. Each time Monica kicks a ball up in the air, okay, so you kick a ball up in the air, it returns to the ground. So the next time Monica kicks a ball up, so she then says, hey, every time I'm trying it out, I'm kicking this ball, it falls back down. the next time she kicks a ball up in the air, it will also return. So is that inductive or deductive? So that should be inductive. She's trying out specific examples, right? She's testing it out. She's actually kicking the ball and she sees specifically, oh, on trial number 1 it falls down, trial number 2 it falls down, therefore I can generally conclude it will always fall down because of gravity. Okay, B, we're starting with all reptiles are cold-blooded. Parrots are not cold-blooded, so Sue's parrot is not a reptile. So what are we using there? So this is deductive, right? We start with a fact or definition. Start with a fact and make a specific conclusion. About Sue's parrot. Okay, so I crossed off this example as well. There'll be some time to practice in the homework, so we'll cross this off. All right, I kept the summary short and sweet. What is inductive reasoning? What is deductive reasoning? So just 2 sentences, make sure they're sentences. What is inductive reasoning? What is deductive reasoning? Okay, so kind of compare and contrast or give an example. All right, the homework, in the past, I've spent 2 days on this section, 1 day on inductive and 1 day on deductive. So for this year, we're combining it, but I am shortening the problem set. So you'll just go on big ideas, and the problems to do will be there, and it will be less than this, okay? If you need more help, you can always email me or hop on a Google Meet or office hour. Have a great day.